Okay. YouTube tells me that I'm live here, so I'm going to go ahead and get started. The start of this will just be some basic information about the course. I'm going to take myself off screen because that's super creepy. And then we're going to jump right into it. So welcome to ITC 298. I'm Thomas Wilburn. A bunch of you have had me before. So if you haven't, it's nice to meet you. During the daytime, I am a news web developer down at the Seattle Times at the bottom of the hill. At night, I come up here and I teach JavaScript, and I'm really thrilled to be teaching this class. It is one of the classes that I've really wanted to teach most since I joined Seattle Central. I'm finally getting to do it, so I'm really looking forward to the idea that the kinds of things that I actually do every day using JavaScript on the server and on the client, we're going to learn how to put those things together. So I want to talk a little bit about the goals and the outcomes for this class. The goal of this class is to work on taking your JavaScript knowledge, which at this point you should have had at the very least Web 150, right? You should understand the basics of JavaScript coding for the browser. You know variables, you know functions, you can put those together in a vague sort of way, right? I'm not expecting a lot, but you should be able to write the language and have it do something reasonably specific. You understand how objects work, that kind of thing. I want to take that and I want to broaden that out into the world of where modern JavaScript is today. Since roughly, for about the last 5 years, there's been kind of a huge revolution in the way that JavaScript is written out in the world. And a large part of that revolution comes from frameworks like Node.js, which allows us to run JavaScript on a server or on our desktop. And what that means is that right now, the modern JavaScript landscape is basically supported by 3 pillars, right? That it's written in 3 ways. The first of those is on the server. So we have Node.js serving where PHP and Python and other frameworks, Ruby on Rails live, right? You have Node that's alongside of that. So you can run JavaScript to create pages, act as an API endpoint, all of those good things. The second thing is that client-side JavaScript has become much bigger and more extravagant, right? People are writing applications in JavaScript for the browser or for native platforms through thin browser shells like React Native or what used to be called Node WebKit is now NWJS. And then the third part of that is build tools, because there was a period of time of about 5 to 10 years where if you wanted to be able to use a lot of the really kind of cool web tooling, like if you wanted to use Compass or Sass or those kinds of like very user-friendly, developer-friendly tools, those things were really for one platform. There were a lot of developers who were working on Macs. That's what they wrote this code for. That's where it stayed. You had to kind of be in that community. And that's great, but it's not very democratic. And it also means that because those things are native, it means that you also had to be, in order to write those tools, a C or a C++ programmer, right? You had to know native code. The use of Node on the desktop as a build step to create tools that we can use to package and transform our code changes all of that. Because now we have one tool, Node, that can run on any platform where we want to be, right? It's on Mac, it's on Windows, it's on Linux. And we can run the same JavaScript code, which means that if you're good in the browser at developing, you can also be good at developing tooling. And so now there's this enormous proliferation of tools that are built around Node, allowing us as web developers to become enormously more productive, no matter where we are. And to really become, I think, it creates a kind of fusion of those things, because when you have a server that runs one language, you have your client runs the language, and then your build step, these are all unified. You don't do context switching, right? I don't have to switch between the client and the server and do the thing that I always used to do, where if I switched from JavaScript to PHP, I had to remember, okay, it's not dots, it's arrows. It's not this, it's that. You know, my array syntax is slightly different. I don't have to switch languages anymore. But in addition to that, it creates, instead of writing applications that are a little chunk in a browser in one language and a chunk on the server in one language, we're now basically writing them as a whole, right? We've combined those two things, and the client and the server are now basically running that application in two places, but it's still one application that we're writing in one language. I think that's incredibly powerful and fascinating and frankly, a lot of fun. And so I'm looking forward to this quarter. We're going to try and get you all acquainted with all three of those, and we're going to try and actually build an application that you will be able to take with you and show off to show that you know all three of those pillars. So I've spoken a little bit about the requirements. If you need to brush up on any of these, let me know, and I'll arrange a time to talk to you later. But you need to understand the fundamental types, be able to write a function, write a loop, use object arrays, and you need to know about this. Arguments would be nice to know about. It's probably not actually required. You need to have a computer on which you can install software. Here in the lab, all of these computers have Node installed. I would also recommend installing Atom. You will have to do that every week, but it's good to have a real editor instead of either Notepad++ or God help you, Crimson Editor. And you will need a GitHub account for this class. When we turn in and work on projects, we're going to do that the way that people work on projects in the real world, which means that you're going to check into a GitHub repo. And you're going to invite me to collaborate and to comment on your commits, and I can file pull requests, and I can fork your code. Do all of the things that normal people do in order to communicate in the real world. Likewise with Git, most of you have had me before, so most of you know that I'm a huge GitHub fanatic, and I've probably made you use GitHub. If you have not, let me know, and I will run you through the basics. It doesn't take terribly long, and the clients for Windows and Mac are relatively easy to use, right? Still possible to get into trouble. Everybody panics at least once a quarter. It's not a big deal. Just send me an email at any time, and I will help you through that. So, what are we going to cover in this course? The basic progression that I want to go through, we're going to start on the server side because I actually think it's the easiest place to kick off. So we're going to start with an intro to Node, and today we're going to go through the basics of starting our first script, using our first modules, and understanding how callbacks work in Node. We're going to move through using this Happy.js, I don't know, it's HAPI.js. This is a framework just for serving pages and serving JSON, so we're going to use it to build our server. We're going to move quickly through Grunt so we can talk about how a build task works, and then we're going to switch to the client, and we're going to start developing on top of the server that you're building. We're going to start building a client-side application that can talk to that, be responsive and fast and useful. We're going to go through that at the rate of once a week. This is a rough outline. It's my first time teaching this course, which means that probably things will change. So right now, this is my idea, but as I get to know what your skill level is and we adjust to that, certain things may take longer or we may go faster through things. That would be fantastic. On Tuesdays, like this week, we are going to have a lecture. So we will work through something together, but I'll talk about one of these things and introduce you to the concept. On Thursdays, we'll do directed labs. So at the start of each Thursday, I'm going to issue you guys a challenge. And then you will either individually or in small groups work to solve that by the end of the class. And I will walk around and help and offer whatever guidance we need to make sure that that happens. And so that way, you're going to constantly be writing code, and you're going to constantly be writing original code. The other goal of this class is that by the end of it, you should have written this application yourself. You're not going to use my framework. You're not going to use anyone else's framework. You're going to write, well, I mean, you'll use some frameworks, right? But you're not going to use, these are going to be like regular business quality, open source frameworks that you depend on, but then everything on top of that, you're going to write yourself. It is not going to be a case where anything is handed to you, I hope. And then finally, at the end of the quarter, you're going to turn in a final project. So this is what we're going to work on all quarter. The goal of the final project is to be a portfolio piece. When you walk into a job interview and you apply and you say, I know Node, and they're like, prove it. I want you to be able to point to your GitHub repo and say, this is an application that I developed in class. It's a real application. It does something. It uses these technologies. Let me tell you about it. And because you've written it all yourself, you're going to know about it. You're going to be able to describe it at every level. And that's the kind of thing that is an enormous asset that I really wish I had had when I was first starting out. So hopefully I can leave you guys with that at the end of the quarter. That and participation are your only grades. There's no homework other than that. But that does mean that the final project needs to be good. So don't wait until the last week of the quarter to start on it. Yes,
so just only one project.
One project.
No homework.
No homework.
Final. Okay.
Just the final project.
So, and what we're gonna do on Thursday?
So on Thursday, we're going to do directed labs. So it's not homework, but I'll come in basically with a problem.
It's not related with the final project?
It's not related to the final project. It will be related to what we talk about on Tuesdays.
Oh, okay.
So we don't have class on Thursday. I apologize. That's a really crappy way to start the quarter, but I have a conference in DC that I have to go to, so I'm out. We will next Thursday. So if we had, and there's actually a lab in the folder for this chapter, we would have worked on writing a web scraper this week. So we would have explored modules and asynchronicity by writing something that goes to Wikipedia and tells you who was born and died on this day in all of history, which was kind of a fun little challenge. So yes, if you do not have to decide on your final project right away, right? You can come up with your own, or I have 5 project specifications in the project specs folder of this repository. All of my class materials are on GitHub in the ITC 298-materials repo. Everything that I do is going to go in there. I'm going to keep adding to that throughout the quarter. So all the documentation, anything that you need, there's no textbook, but I'm going to try and provide documentation and tutorials here, and I'll also provide links each week to things that I think are useful so that I don't basically fall over under the pressure of having to write all of your material each week. So I will have whatever I can there. This week there's an intro to Node folder in case you need to go over what we're going to cover in class today. But there are also these 5 project specifications. So there is a blog application, a multi-user chat, a MUD. For those of you who remember, it's like, you know, the old text games, but multiple people can be in it at once. Like, it's super old school. I did that in high school. A scraper that will go out and download things from web pages and alert you when those things have been updated. And then the last one is kind of an inside joke. It's a secret notepad. So it's a thing where if you have the password to a, you can basically go in, create a pad, encrypt it with a password. The person on the server has no idea what's in there, but another person with the password can unlock it and read the contents of your notepad. So it's basically a way of passing notes in class to somebody else without anyone else being able to read it. So these are your 5 intro project specifications. Each one has is laid out as a very rough kind of agile set of requirements. So I've got a difficulty for how much I think it is out of 5. Not scientific. I have no idea. I just took a random guess. The abstract is the description of what it should do in kind of plain English. The must-haves are features that I really want to see. The nice-to-haves are things where if it turns out that you are just speeding ahead and you need some extra challenges, you pick up the nice-to-haves, right? But this is how agile development works. You have must-haves each sprint, and then you have nice-to-haves, and you try and get through those as best you can. So take a look at those. Like I said, you don't have to decide right away, but the goal is that by, let's say, like week 4, you should start to have an idea of what it is that you want to write, what it is that you want your final project to be. So, cool. Are there any questions about any of that so far? Pretty straightforward? Okay. This is the lectures for this class will hopefully be structured and sequenced, but the rest of the class, obviously, with no homework and stuff, is a little bit up in the air. That's in part because, as some of you either are aware or may have noticed, this is a really big class. And the reason why this is really big is because we have some students in here taking this for an independent study. So they are receiving credits. They will try and show up whenever they can, I hope. And they will be graded at the end optionally if they choose to complete the independent study. But they are not actually in the core group of 17. And so as a result, to keep, again, from killing myself every Wednesday grading all your stuff, we're just going to keep it a little casual here. Okay? Cool? Yes?
I did have one question. So
absolutely.
The example assignments, are those possible example end projects, or are those things that we want to do along the way?
Those are example end projects. So the labs that we're going to do each week will actually be, so if you look up here, I've got in these folders, I've got like intro to Node is what we're working on this week. And I've got, in addition to some example code that you can read through, I have the basics, and I'll try and figure out a way to guide you guys through this a little bit more. I'm also sending out the emails. You should have gotten an email from MailChimp this week that would guide you through the various things that we were going to do, kind of introduce you to the quarter. I'll probably try and include these file names. I'm going to send out those newsletters probably once a week, and so that way you'll know what's in the folder and which folder we're talking about. But for example, the lab here is walking you through. It talks about what it's going to do. Here are the required modules. Here are the steps that we can go through to kind of get that done. So it's as directed as I can get it without giving you the assignment. Cool. 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 Okay. With that in mind, let's go ahead and get started because we have got a ton of stuff to cover this quarter, and I really want to get through it. Oh man, I was so close. What do you want?
So, you recorded yourself?
I am recording this. Yes.
We're gonna be able recording.
So I will paste. They're being recorded in a Google Hangout, which means that it goes to YouTube. I don't necessarily want you guys to go to my YouTube channel. Not that there's anything wrong with it. I'm not keeping. It's just I feel like that's kind of weird to have people subscribing to YouTube. So I will probably create like a video list in that repo, and I'll add links to all the videos as they show up. So each week, as soon as the video has been edited and fully published to YouTube, I will make that link available. But yes, we are currently on air, everyone. Ta-da! So here I am. Let's switch to the screen share so that this will be slightly less embarrassing, and also so that we can actually talk about what we're going to do. So if you go to your start menu and you search real quick, you are going to find something called git bash. You can just type git and it should be the first thing there. We're going to do a lot of stuff in git bash this quarter. So one of the things that I'm going to do from the start is we're going to talk a little bit about the command line. And I'm going to walk you through. I do not actually have a guide to the command line in the repo yet, but I will have that because I know that for a lot of you, this is not something that you have a lot of experience with. It's a little bit frightening. But I will tell you this. The command line is essential to what we're going to do. When we run node programs, when we run our build steps, those things run from the command line. Most of these tools are built using the command line. The other important thing about it, besides the fact that it's fantastically useful, is it makes you feel like you're starring in Hackers. So I feel like that's a huge self-esteem boost, right? When I'm sitting there like typing away and you feel like you're just hacking the Gibson. It's kind of a nice feeling. So it makes you feel hardcore, and I like that. But let's go ahead and get started. So you should see your screen is going to be white text on black backgrounds. Mine is black on a white background because that doesn't project very well. And you should see something like this. It'll probably have a message about Git at the top when you start it up. But it's going to start something like this, and this is your shell, right? When we talk about a command line, and this is specifically, this is the bash shell. Bash stands for the born again shell. Yes? So on the Mac, this is your terminal. Yeah, the terminal is also a bash shell. The born again shell is not named after a religious propensity. It's named after a guy named Steve Bourne, who actually invented it. So it's just kind of a random joke. I can't tell at his expense or not. But this is a common shell, meaning a common command line interface that is used across Mac and Linux, and then also we're going to use it on Windows. Yes, Curtis?
I can't connect to the internet.
You should not need to connect to the internet.
Oh.
This is all things that you're going to do locally. There is a new Wi-Fi password. I don't remember what it is. They change it every quarter. It's like persistence with a capital P and a 1 instead of the I.
Yeah.
Yeah, okay. So every quarter they just decide to mess with me. But you should not need internet access as long as you have Node installed. We're not going to do anything. Well, you'll need it for NPM. So then you should use the Windows computer in front of you instead of using your home laptop. Okay, you do need to have Node installed. I am assuming, for the sake of argument, that you have Node because I do not have time to walk you through installing it. Do that at home. Do it on your own time. Cool.
Do they still have a guest?
Yes. So if you log in with Open and then Open again, you can log in as a guest on these machines if you are not enrolled this quarter. Otherwise, we will find a solution for you at some point.
They can log in.
Yeah, for the first 2 weeks, you can log in whether you're enrolled or not. Open and no password, I believe. Okay, so just to take a quick poll, how many people in the room have never used the command line? The command line, the shell. How many of you feel like comfortable like navigating directories, like you can change directories? That's a significant amount who don't. So how many people don't feel comfortable doing that? Okay, cool. Well, we're gonna go through it real quick. It's not that hard. So your prompt here, like mine reads open at the room number and then this weird thing, because that's my computer name. And then it follows with where I am. And then the $ is my actual prompt. So that's what I'm going to type things after. And if you see this in my documentation, right, if you see me write in a little code block and it starts with a $, I'm probably writing something that you should type on the prompt. But clearly, you should not type the $, right? That's not going to do you any good. The $ starts there and you type after it. So if we want to find out where we are in a shell, the first thing we can do is we can say pwd for what is my present working directory. Where am I? And it should tell you a location of some kind. I forget where it starts you. We are going to go to the desktop and we're going to make a folder to put that we're going to work in today. So you're going to type cd and tilde, which is shift and the key next to the 1. And that means change directory. So cd is change directory. And then the tilde is a special shortcut. It means take me home. Your home directory is your user directory on these computers. Should be on any computer, right? Your home directory is your user directory. Inside here, we're going to go to your desktop or wherever it is that you like to locate these things. But for those of you who are on the Windows machines, we're going to cd to the desktop. And you are going to make a directory. The other thing is you'll see me type very fast, but some of that is an illusion, something that is super cool. So if I go back up to my home directory real quick, these are all the things that are in that directory, right? So there's like my documents, my desktop. If you type ls, you get a listing of everything that's in the directory. When I start navigating somewhere, a lot of times what I'll do is I'll say cd and then I'll type the first couple letters and hit tab. And that should autocomplete. If I don't type enough and there are more than one options, it'll list them for me. It'll say, okay, well, if I say cdd, then I could go to desktop, documents, downloads, or DL manager _ pro. I don't know what that is. I don't really care. I'm going to go into my desktop. So cd desktop. And then to make a directory, it's important to remember all of these commands were invented by people who had a terrible case of carpal tunnel. So they are all very short. There aren't a lot of vowels, but it's basically so that you can just type as little as possible. But you start to kind of get them. They're kind of, you can at least pronounce them most of the time. To make a directory, it's mkdir, and the name of the directory that you want to make. And I usually name these after the day of class. You can name it whatever you want, but I'm going to call mine 04. Yes, I can do that, such as it is. There we go. So I'm just going to name mine 040715. I forgot what year it was. But you can name it whatever it is that you want to call it. It doesn't really matter. I already have that directory, so it tells me, but it should allow you to make it. And then once you've created that directory, you can change directory into it. So I can say cd Now, all of this navigating around can start to feel a little bit like a hassle. If you are working on your own project with GitHub, one of the nice things that it will do is it will allow you to open a shell directly into a project. So in either the Mac or the Windows client, when you have GitHub installed and when you start working on your project, or if you have a repo like mine that you check all of your classwork into, you can right-click on that repo name and it will say like open terminal or open shell here. And then it will open it directly to that directory so that instead of having to navigate around with all of this malarkey, you can just jump directly in the terminal straight to where you want to be, which is a really handy thing to do. But at this point, as you can see from my shell, I'm in home, desktop, this directory that I've made. And now that we're inside here, let's actually start Node. So let's start poking around a little bit in it. So go into your, at your shell, just go ahead and type Node. And it should change the prompt. Now instead of the $, you should have a caret or an angle bracket sitting there. Let me zoom this up so that it's a little bit more visible for you guys. All right. So now we are inside of Node, and it's decided to snap to, that's really obnoxious. Cool. All right, so Node is JavaScript that we run on the server. When you type Node like this, you are entering the interactive mode. So this is basically like in your DevTools in your browser where you have the JavaScript console and you can type things and echo them back. How many people have used that, right? Like you've used the console in the browser. Seriously, like hands up so I can see. A bunch of you have not used the console? That is creepy. Like, it's amazing. It's so useful to be able to test the things that you've got. No, absolutely. So if you haven't done this before, right? Like if you go into a browser and you open up the DevTools, so you inspect an element, you've got this tab for the console where you can just go and it's the same thing, right? Like you've got a caret, and if I want to type console.log hello world, then it logs out hello world, right? Like I can test my JavaScript code here. So when we run the Node command, that's basically what we're doing on the desktop. Instead of running a JavaScript console in our browser, we're running it in the Node kind of like scripting environment, which is where we run our scripts. So all of the things that we're going to do on the server, we're going to start them using the Node command. We're not all going to do them from this command line, but we are going to start them from the Node command. I think at this point it's useful to talk about kind of the way that Node, well, we'll get back to that. The way that Node talks about servers may be a little different from what you're used to, but for right now, let's just explore a little bit. So from this console, we can type the same kind of thing that we could type in the browser. So for example, I can say console.log hello world, and it will log out hello world, right? That all just works. And I can type regular, just normal JavaScript expressions too, right? So if I do 1 + 1, and it logs 2, because it evaluates each expression as I go through it. If I were to decide to add some strings, so I could say, this is the REPL plus that, right? I can add strings. I can get the same kind of errors that I would have in a browser. Like if I try and subtract something from a string, I get not a number. Nan, my favorite delicious bread treat, or not a number, one of the two.
That's a question.
Yes.
Node is a program that we're running from the command line?
Node is a program that we're running. So Node is actually, this was kind of what I was going to get at earlier, and now it sounds like I should go back to it. So thank you. And thank you for asking questions, by the way. The more that you guys want to ask questions, that's great, because this is new material, and if I miss something or confuse you, I really don't want to leave you behind and then get to the end of class and realize that you've all been blanking for an hour and a half. So please keep it interactive. So when you run a regular web page. That runs in PHP, right? Or it might run somewhere else, right? There's a program that serves those things up. There's a server somewhere that runs. So your PHP file might get run by the PHP interpreter, or your regular HTML file might get served to you in the browser. On the server, there's an Apache program that reads that file and then sends it over the network to you, right? So there's a program that's involved that is basically serving as the runtime. It's the server. We tend to think of server in two ways. There's the physical server, right? The actual machine where things happen. And that's the hardware, and that's important. But just as important is the software server, which is that there's a program that's actually running on that machine, or a lot of times multiple software servers running on that machine that are performing different aspects of your web application. And so in this case, yes, we are running the Node application, and it is a front end to the scripting engine. You can actually also do this with PHP. If you do PHP space -I, that's interactive mode, and then you have a PHP shell that runs like this. If you run Python by itself, it'll give you an interactive shell. This is a really standard thing for desktop scripting languages because it gives you a great place to test code and try things out. So this environment is actually called a REPL, an REPL. And that stands for read, because it reads your inputs. Evaluate, because it evaluates and finds out what the value of whatever you typed there is. Print, because then it takes that value and it serves it up to you on the next line. And loop, because after it has printed, it goes back to wait to read your next line. So this is an interactive shell, or a REPL, where we can try some stuff out with Node. Now, even though this is still JavaScript, right, and all of the normal things that we would expect to work in JavaScript do, so I can create an array, that works. I can create an object, hello world, right, piece of cake. But it's not entirely like browser JavaScript. So there are things that you might be used to having, like, for example, the document. Well, there's no document here. We don't have a page. We're running on a server. Yes, Patricia.
You forgot to close that.
Like a quote or something, hit Control-C to cancel that input. Did that work? Cool. Yeah, so at any time if you get into trouble, hit Control-C. If you hit it twice, it'll quit. So if you ever need to get out of this, just like hammer Control-C until it stops moving, basically. Same thing that I do when there's vermin in the house. So like I said, we don't have a document. Right? We're not in a browser. There's no page. We don't have a window. If you're used to, say, adding a resize listener to the window, right? There is no window. There's no user interface here. We're running in text mode. We are close to the metal. So a lot of the things that you're used to having from browsers are not there. But there are some things here that are new. So we don't have a document or a window, but we do have a process, which is a variable that represents kind of the program that we're running right now. And if you type process, it will list out a huge screen full of junk. There's a lot of information on the process. And if you scroll up, you're going to see it has all this information about your computer, what your environment looks like, what your variables are, the version that you're currently using, the title of your window, right? There's a bunch of stuff in the process. This is one of the few kind of like global variables that we start out with. But honestly, for the most part, other than that, there's not a lot here, right? Node starts basically empty. And then it's our job to fill it in, to provide extra stuff that we can actually use. The only other thing really that's here is the console. So we have a console just like we have in the browser. We've got a process, which is a new thing because we don't have a document in a window. Other than that, nothing here. Empty environment. Do with it what you will, right? Total blank slate. So if you want, you can spend a little time while I'm yammering away. You can try out a few little JavaScript expressions, right? Like we can assign variables in this mode. We can say var x equals 12. And then if we log out x plus 2, we'll get 14, right? This is a live environment. It's basically like you're writing code and then immediately evaluating it, but it's persistent. So any changes that you make are going to continue on to the next line, right? They don't go away. Anything that you do will just keep going, which is great because it is a really handy way to test your code if you want to try something out. Or I actually use this a lot. Like a lot of times at work, I need to rename files. My photo department will save out JPEGs and the JPG will be all capitalized. It drives me crazy. But I don't know a good way to like batch change them all to lowercase. But if I go into Node, I know JavaScript well enough that I can write like 4 lines in the REPL and have it go through and rename all the files for me, which is super helpful. So, so you can actually use this as a general purpose, just kind of place to get stuff done if you have utility stuff that you want to do. But other than that, the REPL is a place to experiment. And anytime that you just type Node without anything after it, this is where you'll end up. So you'll end up in your scratch pad, basically. Cool.
So,
And-
sorry, you say
Yeah.
it stays with you, that information is available, so it's available, I'm assuming,
Until we close it.
yeah.
And when we close it, it'll throw all of that state away. So any variables that I declare will be here as long as Node is running. But then once I quit, it'll destroy them. Good question.
Save it if you need to.
Could you save it if you need to? Not in a particularly useful way. We're going to talk about how to execute actual script files in a minute, and that's where saved state becomes more useful because that's actually where you can run a process that can persist itself to disk. Okay, cool. Any other questions? No? Okay, cool. So, we've got this blank slate, but we actually, I keep talking about how useful Node is for getting stuff done, right? Where we can use this to build our CSS and run our servers and make Julian fries, all of these things that it's supposed to be able to do. How am I supposed to get that done if there's nothing available? And the answer to that comes from modules. So the idea of Node is that by default, everything is very small and constrained. But if I want, I can load additional functionality that comes with Node standard to actually get stuff done. If I look at the Node.js webpage, so if you look at the docs and then the API docs, this will show a list of all of the built-in stuff that comes with Node. And these are just the start. There's a whole world, just like there is on the client, of third-party libraries that do bigger and better things. But these are the foundation. Everything gets built on these modules. The ones that are going to be of particular interest to you, at least when we're getting started out, are the file system. So if I want to save files or load files or edit them, right, that's where that's useful. There is the path module, which you can use to put together paths. So if you need to construct like a directory and then another directory and a file name from its individual pieces, you don't have to worry about like, well, what if I get like 2 slashes next to each other or all that stuff. You feed it to path, path will join those things, split them apart. It manipulates file paths, which is surprisingly useful, particularly in combination with the file. And URL. So these are all the kinds of things like if I wanted to parse a URL, to break it down into its component parts, to decode it, or to construct one, I could make a URL. And you'll notice that most of these modules, or a huge number of these modules, are network oriented. Node is evolved in an environment where, unlike, say, Python, or unlike Ruby, the primary use and environment for Node was on the internet, right? This is a server that was invented because people wanted to be able to use a web language to make web pages. And so it tends to be kind of laser focused on what are things that we can do on the internet. How do we request pages? How do we deal with the kind of things that are attached to pages like URLs or page content? Query strings is a built-in module. That's the kind of thing that you see in an environment where the internet is kind of our top priority of dealing with the World Wide Web. So to load one of these modules, we can go back to our console and we create a variable to nickname it. And the way that we load it is that we use the require function. So I'm going to load the file system by saying var fs So create an fs variable and set it equal to the result of requiring fs as a string. That means load the file system module and make it available to me under the name fs. You can name these modules anything you want. If you wanted to interact with the file system, but you want to do it through fuzzy bunnies, you can do that. Anyone who uses your code will think you are completely bonkers, but you can do it, right? There's nothing stopping you. But typically when we require modules, we create variables that have the same name because it's just easier to get to them. And if you type fs now that you've required that, it will list all of the things that are in the file system module. So there's a lot of functions that are in here, right? For reading files, opening and closing files, writing files, renaming them. You'll recognize some of these from the command line, right? You've got make directory is the function that you can call. You can remove a directory. You can read them to detect their contents, create symlinks. You get into some of these weird ones like chmod that you've probably seen when you FTP stuff, or chown. But all of these are the things that are available on the file object. So let's create a file and read it real quick. We've got our file system module. So open up the folder, which for me is on the desktop, right? Like I am currently in this 04, this snap thing is killing me. This 040715, and I'm going to create a new file that I'm going to save there. I'm using Atom to save it. So I'm going to save this into that folder. I'm going to call it sample.txt. And then I'm just going to write something into it. Doesn't matter what you write. Here we go. So at this point, I now have in the folder that we navigated to, and that's part of the thing that's important. In that folder, I should have sample.txt. So I've got a file there that's available for us to read because we need to have something there before we can read it. And then we're going to use one of the APIs that's on the file system object to actually read that. Now, if you go back to the documentation and we click into file system, it's going to list all of these things. And I'm going to find a read file, which is somewhere in here. There we go. And you'll see that read file takes, I want you guys to get used to reading through this documentation, right? Reading documentation, unfortunately, it's not terribly friendly, but it is the way that as developers, we learn most of the things that we need to do. I spend a lot of time in these docs because I don't have them memorized. You shouldn't be expected to. You're going to want to be able to look things up. So a read file is a function and it takes 3 arguments. The first argument is the file name. What do I want to read? The second, which is in square brackets, meaning that it's optional, is an options object. So that can either be the encoding and the flag, or if you pass that in as a string, you can actually, you can just tell it what encoding. This is going to be really important. You have to tell Node how to read the file. We're going to always use UTF-8. Does everyone know what UTF-8 is? Have you ever heard of that other than like having to set the Medicare set? Okay, cool. Let's talk about UTF-8 real quick. Quick diversion. Once upon a time, everybody thought that computers were only used by people who spoke English. And this was really unfortunate. But what it meant was that when we stored text in files, we just used 1 byte per letter, which is great. 1 byte can contain 256 different IDs, different letters, right? Because you have from 0 to 255. And that is plenty because you only need 26 for lowercase, 26 for uppercase, and then some punctuation. And then you've actually got like still 200 characters left that you can just mess around with. So people were like, this is great. And then people in other countries that did not have a simple 26-letter alphabet started using computers, and they were like, this sucks because you created an encoding scheme where you say, well, a letter is equal to 1 byte, but my language has diacritical marks. So I might have umlauts on top of things or accents on top of certain letters, and you didn't leave space for that. Or my language might be combinatorial, like Korean or Chinese or Japanese. And I have thousands of letters, and you only gave me room for 256. What am I supposed to do with this puny 256 letter encoding? And so UTF is the universal text format. It's an attempt to change that. Instead of using 1 byte per character, it allows us to expand that out to handle any of the thousands of possible characters that you could have in an international text encoding set. And UTF-8 is a specific subset of UTF that we're going to use a lot. It's kind of the standard for when you're writing text in a modern editor. It usually saves out as UTF-8. We need to tell Node what type of encoding before we read a file. It's kind of the one user-unfriendly part of this whole process. That part's kind of awkward. But you'll see how it works. And then the last thing is a callback. And we're going to talk about that in a second. So let's try and read the file. We're going to go back to our console, and we're going to say fs.read file. We're going to pass in a file name. I called mine sample.txt. Let's carry this up so you can see it. Then I need to tell it what the encoding is. I'm going to tell it UTF-8. I'm pretty much just, you're going to have to get used to typing that because you're going to do it a lot.
Are we always using camel case like that?
The read file?
Yeah.
Yes, because that's so although you can rename the module object itself, the things that are in the module are named what they're named. And so it is camel case. And camel case is the default for JavaScript style in Node. So if you like naming things snake case, like in PHP, you just need to get used to the fact that it's not a thing here. And then the last thing is the callback. And the callback is a function that's actually going to get the result. What you might expect if this were another programming language is we would be like, var contents is equal to fs read file. Do not type this. I'm demonstrating. And if I do this, contents is nothing. I can't just set something equal to reading the file. The other interesting thing about Node, so there are a couple of interesting things about Node that we've talked about so far, right? One is the fact that it's internet focused from the start. But another one is that Node is what we call non-blocking. So in other programming languages, when we read a file off the hard drive, like in PHP, if you do an fread or an fopen and an fread, and you read that file in, the script reads the file and it waits for you while the file reads, right? So it sits there and it reads it all, and then when it's done, it sets your variable equal to it. And it all happens, it blocks. So it stops the world, basically, for your script while it waits for that file to be read. Node does not work that way. The idea of Node is that it was originally invented for people to do long file uploads to like Yahoo, right? They wanted to upload to like Flickr. So they were going to upload these files. And in a regular blocking language, uploads tend to be handled the same way that files are, which means that when that upload starts, that script has to sit there and wait for that upload to finish. And if that takes like 5 minutes, then you have basically tied up that server for 5 minutes. And nobody else can use that process. Now, the typical PHP server runs like 20 processes, but still, you've locked yourself to like 20 people. And once all of those processes are tied up, once everybody's uploading, you're clogged, and you can't fit anyone else in. That's not okay. So the idea in Node is that instead of blocking, instead of stopping the script, we're going to use callbacks the same way that we use events on the client, meaning that we will pass in a function to be called when the file is done reading. Now, while the file is reading, that's something that happens off, like not in JavaScript land, right? Like that's done in the underlying C++ layer that Node is written in. While that file is being read and loaded up for us, Node will actually handle other requests. So the idea in our upload scenario is as each chunk of a file is sent, Node would handle each chunk, and then while it's waiting for the next one to arrive over the network, it would process other people's chunks. And so it could handle way more people than it had processes, because during its downtime, while it's waiting for the network or waiting for the hard drive, waiting for any of these things that actually take way, way longer than our computer can react, right? Computers are so fast these days, but hard drives haven't really gotten that faster. Networks haven't really gotten that much faster. And so most of the time, when you're writing scripts in a blocking language, you're waiting on the hard drive. Node says, while we wait, let's do something else. So we pass in a callback function, and that's where we get our value. Let's actually do that now. So we're going to say fs.readFile. That's in the file name. We're going to say UTF-8. And then the third argument, the last argument, is a function. This function takes two arguments, an error and a data. And then I'm going to console.log data. I know this line is getting very long. I'm sorry about that. Pay attention to the way that your syntax goes, right? So you're going to need to open the file, console.log. When you close that parentheses, you still need to close the function before you can then close again the read file. It may take you a couple tries to get that right. Yes.
I missed the part of, I never use backup, so I missed the part of using backup and then make the file. So
You can use anything to make the file. It doesn't have to be app. Just save
Save it,
something,
whatever.
something to that directory as a file
Same
name.
name as something.
Yes.
Okay.
Yes.
Yeah, thank you.
Yeah, no problem. So when we run this now, it will, the first thing it says is undefined, because there's nothing returned from this function, right? Like nothing comes back. There's nothing that this is equal to. Instead, while it's reading the file, it kind of does its own thing, and then it logs out this space intentionally left blank. That's coming out of this function here. So this is what we call the callback, right? The last argument to our node function is the thing that we want to do once we have the result. So once the disk finishes reading or the network finishes transferring. Yes?
So as we're entering this, we're going to do the full string before we hit.
Before you hit it, yes. If you hit enter early, it'll probably error out. Yeah, it wraps in a funny way on mine. Hopefully you can actually fit it all on one line. And we can actually see, I want to demonstrate, like I want to really show that that's what's happening here. So I'm going to go here, I hit up to redo my last line. And in my console.log, I'm going to add something here. I'm going to say the file contents are, and then I'm going to log out data just so that, whoa, just so that we can actually like really show that, yes, it's this function that got the data, right? It was not returned. We couldn't set anything equal to it. Instead, it got passed to this function here. And that function was called. That function was run when this operation completed. So for those of you who have written jQuery, which I hope is all of you, because that was the prereq, this should look a little bit familiar, right? This is kind of like the way that we do events. When we attach an event listener, right? When we say on click, or links.click, or something.mouseover, and then we pass a function to be called when that thing happens. That's what we're doing here, except instead of happening every time that that event occurs, this happens only once when the operation completes. So when the file is read, or when whatever it is that we want actually happens. Does that make sense to everyone? This is a standard pattern in Node. There are two things that are important about it. First, in Node, almost every, or a huge number of things, and anytime you see the word callback in the API documents, it means that it needs a function that will work like this. The second thing is that almost all callback functions will start, and their first parameter will be an error. And that's used as a flag. If nothing goes wrong, error is null. There's no value to it. And then everything that you got as a result of that function is passed in as the next set of arguments. So here it comes in as data. But the first argument is always the error. So it's if anything went wrong, we can check for it. But otherwise, we make the next thing, the next argument over is where we will actually get the result of our operation. And there are good reasons for why this happens. Having the callback always at the end, so it's always the last parameter, and then always having the error as the first argument to that function means that this is reliably something that you can check for. It's a pattern that you can follow all throughout Node. Your callbacks will always be the last argument, and the first argument to that callback will always be an error flag to tell you if something went wrong, and to tell you what went wrong if something did. Otherwise, it'll be a false value like now. Questions? There are actually, and you'll see them in the documentation, there are synchronous versions of a lot of these APIs. So there's like read file sync, write file sync. Those things don't take callback. They behave like traditional programming languages where like you can read file sync and then set something equal to that and you get the contents of the file right away and it blocks. It's not recommended that you use those for servers because then you throw away what's interesting about Node, right? Which is that it can process other things while it waits. So we will tend to use those in build scripts or in places where the only people who are running it and the only time that we're wasting is our own. But in cases where we're actually running this for multiple users, we're always going to stick to the callback version. We're always going to use, these things are called asynchronous. So synchronous would mean that it waits for us. Asynchronous means that it doesn't. And so almost all of these are asynchronous. And when we talk about async, that's what that means. Now, the further that we get into this, the more that it's going to be a little bit hard to do from the command line. So the next thing that I want to do, we're going to take a short break because I've been talking for an hour and all that good stuff. We're going to take a short break. When we come back, we're going to start working with actual files. So instead of having to type everything on this command line and evaluate it line by line and not hit enter, we're going to actually write a script file the way that you would be used to writing an HTML or a PHP file, and we're going to run that script instead. And we're going to that's going to make it a little bit easier to talk about these things conceptually. But right now it's 7 o'clock. Let's take a quick 5 to 10 minute break. Come back at 7:10, and at that point we will continue. Get your favorite editor open in the meantime if you have it time during this break. I really recommend installing Atom. If you have not already, you don't need admin permissions. If you go to atom.io, there's a nice handy download thing. This is a really nice editor from the people who make GitHub. So get that installed and use it on these machines. If I see you using Crimson Edit, you're plucked. You're out. Done. Okay, see you at 7:10. If you have any questions, I'll come around. Yeah.
But why you decided to make nice one? And you cannot drop it? You just you don't want to wait. So you can take 260. Because I'm taking 260. This bill it's 330 to 5, and then I comment this.
Sorry, I don't know. Sorry.
So,
You're at the just
no, I just kind of thinking you can drop it because apparently you don't need it. It's for design. And you can take better take the PhD class.
Yeah, but I didn't.
Oh,
Yeah, I need that for the degree.
but wait, you need 5 credits. Because mine, in my certification, I need 5 credits. He's not 3 credits. You need to take some
But it's
additional
the
credits.
same.
No, it's 3 credits.
So you need to take 5 credits by
Yes.
CT 98.
Yeah, which yours? Are you taking the certification program?
Yes, see, so it is.
Yes. Oh my
That's where you need to take 2
God.
classes of this.
It takes a while.
Yeah. So I'm doing.
Because I know my friend, she
Yeah, what's up?
298, not like 5, but another teacher. And she was
So the
where she got 2 more credits.
I would recommend that.
5 credits. So you need to take 5. What? Yeah.
Sure.
Do you know anything about how the certificates work here?
Sorry. We've got to talk to somebody in admin about that. I have no idea.
So is this class? Okay, well, this is 3 credits?
5.
5. This is a 5 credit class.
Okay.
Mike's 3 credits.
God,
Because I'm hardcore, man. I'm worth 5 credits.
okay. 'Cause
Don't let anyone tell you I'm not.
I signed up for the ITC 298, like right when it came out, before the instructors and the classes were even determined or everything, but I signed up for the 330 to 450.
Oh, is that the
It's
database?
a Mike's.
Oh,
Mike.
Yeah,
Mike's.
it's Mike's class. I didn't know Mike was teaching one.
Oh, I didn't know either.
Yeah, it's.
What's he teaching?
It's this, he's teaching, it's like a research.
Yeah.
Oh, nice.
Laura doesn't want to teach this one, so she's not teaching that.
Yeah.
Okay.
So I took that one just because I thought it would work, but apparently that's only 3 credits. Well, not for the job, that's
Right.
here, the JavaScript one, but I thought that would work for the certificate.
You
You know what?
taking 298 classes with Mike?
No,
No, you don't need it?
no,
Are you?
I've already taken that.
You took before with Laura.
No, I took, because like that one, that one's not required, that can replace, what is it?
Are you on certification program?
You already got your certificate, right?
Yeah.
For.
Is there a way to update node through NPM or you have to just reinstall it?
Can you
So
hear-
the
you
usual,
know,
on Windows, you just have to install.
Okay, just remove first and then reinstall, or just can I
Not
just?
honestly, just run installer again. It'll just
Okay.
override it.
So, for
Okay, all right,
example.
Yeah, it'll just,
I'm
just let
doing
it
the
plonk right over top of your.
So. this
NPM you can update. NPM updates with itself.
Oh, the packages within it.
this
Well,
might-
NPM itself is an NPM
For-
package. So if you do like
Mhm.
npm install npm-g,
So.
That will
that
update
work
itself.
For this guy?
but that doesn't update your node version. That only updates NPM.
That should work.
Okay.
I mean, technically, that should work.
Okay.
I'd go talk with Lee, go double check it with Lisa.
Yeah.
But, yeah, I mean, technically it fits the requirements.
This was only 3
3
credits.
credits, yeah. But
Mm.
he needs
You know,
to
to be honest, they
get
don't
5
really
credits.
upgrade it. Like they were stuck on.
Yeah, it says.
Interesting.
On here, it says 5.
Yeah. They're supposed to be trying to move to a more.
But in the actual class itself.
But even so,
I think he
Yeah.
said like
at this point, a lot of things are.
Yeah, I think it was 3.
Yeah.
Because I think they, on the programming, they're wanting you to take this 298, which is fine.
Yeah. Because I know my friend she took 298 before and she was TA and she got 2 more credits.
Who was that? That was, yeah. Yeah, and then she got a job like straight out of it
I
too.
think that last day is Friday.
I think Mike,
So we're not gonna be.
Yeah.
but it was kind of like an internship.
Yeah, well, that's why Mike pushes that class so hard,
Yeah.
especially with Laura. Because Laura is a, like,
She said.
Laura is a researcher.
Yeah, she was.
Like, by profession, Laura is a researcher.
Yeah.
Usability research. And so she knows that class well.
Mhm.
Yeah, I had her for 105, and that was really good.
That'll
I
be,
took
we'll say
my-
sets of Thursdays.
Yeah.
Just.
I wish I would have taken this 105 as well.
We're just gonna work through it.
Laura's is a very good 105 to take like at the very end of the quarter because you split up into groups and you go through the entire process.
Oh.
So like you're given a fake client and you write a client survey. You conduct the client survey. You then like create wireframes. You do usability testing using those wireframes. And it's just like it's a very good culmination.
Yeah.
It's totally close.
I haven't really.
Like you look at the money. Hey, I've been walking by. How because I don't go to the horses. Just this insurance.
It feels a little bit like, to be honest with you. It's freaking me out. Like, I know I'm much and in 3 years that has never happened. So I'm just a little bit worried about the whole. It's not a. You need to take my photo of me off the mantle and stop burning the candles. It's okay, right? I'll be fine. You may still bring me gifts, but let's do so in a relatively conservative fashion. It's cool. Appreciate it. All right, let's pick back up again. So we are now going to start running, instead of running things through the read, evaluate, print loop, the REPL, the console, we are going to run them via an actual script file, the way that you would write a PHP program or a C program or any of the other programming languages that exist. Because clearly, although I'm sure it is super fun, it would be really weird for like people in production to have like written their entire application interactively, right? Nobody does that. So we write programs by putting them into files, and we run those files with Node. And that will make it a little bit easier to talk about some of these other things that we've got. So I have created a file in the directory that I was just in, saved it alongside of sample.txt, and I've named it index.js, which is a common name for the starting point of a Node script. The same way that index.html is a common name for a starting point on a web page, or index.php, right? Those are the defaults. And in fact, you can run, if you run a package with Node normally, it will start with index. Like if you just point it towards a folder, it'll run index.js, or it'll look for an index.js and run. So this is a really nice way to kind of like set up for people who are new to your project to say, well, where do I start understanding what's going on? I should probably start by opening up index.js. So inside here, we're just going to write some regular JavaScript. And in fact, we're going to start by rewriting what we wrote in the console. So the first thing we're going to do is we're going to load up that file system module so that we can read files off the hard drive. We're going to say var fs is equal to require fs. I mentioned before that loading and reading files is normally async, right? It can do stuff while it is while it's loading the file, and so we have to use a callback. Require is kind of one of the exceptions to that. If you think about it, requiring a module means that it has to load things off the hard drive, right? Like it doesn't just have those in memory. Actually, for things like a file system, it probably does, but pretend it didn't, right? Like, require is one of the few times where they basically provide a convenience method. They say, you know what, in this one case for loading modules, we'll let you get away with setting something equal to something else. But don't get used to it. And then once we've required that, we are going to use it to read our file. So we're going to go down, we're going to use white space generously because we are good, hardworking people. We're going to say read file. The file that we want to read is sample.txt. The encoding is UTF-8. And the callback is the last thing that goes in here. And so the callback is a function that takes these two arguments. And we're just going to log out the data. Clearly, this is a lot easier to read when we don't have to type everything on one line, right? Like all of a sudden, this is a much easier to read piece of script. Now, in order to run this, we need to go back to our command line, and we are going to cancel. We're going to quit out of Node because we no longer want to work interactively. So I'm going to hit Control-C twice, and it should dump me back. You should see the $ prompt again if it worked. If not, just keep hitting Control-C until it begs for mercy. And then to run this, we're going to use the node command again. But instead of just running node by itself, I'm going to type the JS file that I want to run. So I'm going to say node index.js. I hit enter. It reads my file, and it console.logs it, just like normal. So it just runs my script. And then it immediately exits back out. So it runs it, and then it's done. There are no, if there's nothing left, it immediately exits. And I'll go back to the script for those of you who may be having syntax errors, so you can see what's going on. So when we read this file, we pass in this function, right, that takes our error and our data instead of being able to set something equal to it. This is a really common way of writing it, right? We write a function literal. So instead of giving this a named function, we just write our function directly in there as a literal value. Because as I hope you all remember from your Web 150 class, a function is just another kind of value in JavaScript, just like an object or a number, right? They're all the same kinds of things that can be assigned to variables, and they also have a literal form where you can just write them out. We don't actually have to write it directly in here. If we want, we can move it out into a variable, which sometimes makes it a little easier to keep track of. So we might cut this out, and on the line above it, I'm going to create a new variable. I'm going to say when red is equal to that function. And then I will pass when red by name. Instead of writing the function directly in, I'll just pass in that variable. So I said, okay, so this function is now stored in a variable when red. And then if I pass that in, it's the same as if I wrote it directly in there, right? Same deal. So I can do that either way. I can either write the function directly in, or I can write it, or I can write it as its own separate variable and pass it in by name. And you'll see both of these used a lot. And we'll talk about why one of them might be useful over the other in a little bit. We've talked about, and so far we've used the data, but we have not used the error. And so let's take a look at what that actually looks like. Above line 6, where we have the file contains, let's log out the error real quick. So I'm going to say error is, comma, error. And when you run this, if everything is functioning normally, you should see null, and then on the next line, you'll see the file contents because it worked. So if everything goes swimmingly, then error is null, and we don't have to do anything. These are not names that are set in stone, right? Like you can name your errors or your arguments anything you want in your functions, but it's pretty common to use error as short for error. That's a pretty common pattern. The same way that the use of the name callback is really common in Node. So we run this on the command line, and we should see error is null, file contains this space intentionally left blank. But what if something went wrong? What if, for example, I were to go here and I gave it the wrong file name, so that instead of sample.txt, I forgot the E at the end, because those silent E's are just murder on my phonetic spelling. So I said sample without an e.txt. Well, there's no file by that name, right? So there's going to be an error. Unlike a lot of programming languages, it's not going to throw that error immediately because this is not synchronous. So if I throw it, then I would have to be able to catch it. And usually by the time that I could catch that, I've already moved on, right? So the way that we get information about whether something went wrong is we get it through that first parameter. Now when I run the script, I get error is, and there's this extremely charming error object where it says eno int, open this. Basically, it's saying that it couldn't be found. Unfortunately, the errors in Node are not particularly any more descriptive than the errors in the browser. If you have ever tried to use JavaScript in the browser and felt frustrated at the console, congratulations, that will continue. But at least in this way, we can check and we can say, okay, an error occurred, right? There's a value here. We got an error object that has all of this information about what's the number, what's the code, where did it take place. If I want to make a decision based on that, I can do it by testing the error. So for example, if I was unable to read the file, I probably want to say so, right? I don't want to say file contains undefined, because while data may be undefined, the file contents are not. We weren't able to read them. We don't know what they are. So usually what we're going to do is on this line, a lot of times in Node, we'll have a thing that starts out where we'll say something like this. We'll say if error, then console.log couldn't read file, and then we will return. Those of you who have been in my JavaScript class, what does the return do? Huh? Sorry, somebody spoke up. Don't even say it. Right, it kicks us out. It ends this function. So when we return, normally if we were to return, we would do so to provide a value, right? Like when you do something equals a jQuery search in the browser, that thing that you get back that you set equal into your variable, that's the return value. That's what the function returns. But a return, you can also not provide a value, and then it basically just means leave, right? Leave this function immediately. So in this case, we're actually going to say, like, okay, I couldn't read a file, and I'm going to do that instead of, and then I return before I get here. So I leave. You can actually even shorten this a little bit more. So you can actually just say return console.log. It doesn't matter what the value of console.log is. Since we're working asynchronously, we're not setting anything equal to the value of this anyway, right? Because we don't do that in Node. We pass callbacks to get the values of functions. We don't set things equal to the result of functions most of the time. And so if we return here, it's just a one-liner that says, and in fact, you can even shorten it. If you leave off the braces, I don't actually recommend doing this because it makes your code kind of unfriendly, but you can even just do this. You'll see me do this a lot because I'm lazy and I write code myself, but I don't, I recommend not doing it too much because this will only run this line. Anything that goes after it, you have to add the braces back, right? It only runs the one statement after the if, unless you have the braces to collect more statements. Anyway, so we're just leaving immediately. And so now when we run this from our console, we go back, we say node index.js. You can hit up, by the way, in the console, and it will reload the previous thing that you typed. You can even flip through like your whole history, which is kind of handy. And instead of trying to like tell me what the file contains, it just says couldn't read file, right? So we handled that error. And if we fix it, so we put our file back, we get reminded that there is in fact a silent E at the end of sample. And so we go back and we run it this time. We don't see the couldn't read file error because error now is null, and null is one of our falsy values. Anyone remember what the falsy values in JavaScript are? Anyone? Man, y'all are a quiet bunch. Falsy values. So JavaScript is a loosely typed language, right? It does not have definite types. It's not like Java where we have like classes and everything's set in stone. We're very kind of loosey-goosey with our types, but that means that there are certain things that are considered false enough that they trigger the false path of an if statement, right? So those things are obviously false, right? 0 is a falsy value. Null, and null is what our error is if nothing goes wrong, so that's false, and that's why it doesn't run our error condition.
Non.
I beg your pardon?
Non.
Non, yes, so non is a falsy value, unless I'm hungry. What else? Empty string. So a string with nothing in it, just two quotes right up next to each other, that's falsy. And undefined is a falsy value, the special undefined value. So because our error is null when things go right, then we can continue through the rest of the function. The reason why errors are always the first thing in a callback is because it lets us get that out of the way, right? It forces us, it reminds us that this thing could go wrong, right? Things could happen. It doesn't even have to be that the file exists. Maybe your hard drive is corrupted. Maybe it fell off the table while you were doing this and it got disconnected. Maybe, I don't know, maybe it's not actually UTF-8 and it couldn't read it. There's any number of things that could go wrong with a file read. And so errors could happen at any time. So by putting it first, Node forces us to deal with it. It forces us to think about, well, what happens? And to be fair, a lot of times you can ignore it. Because although I talk about all the things that can go wrong with a file read, like at this point in time, computers are pretty good at reading files, right? We've had some practice at it, we're decent. Most of the time we know that a file read is gonna work. But it's true that, so it's true that a lot of times we may leave that off. We may just ignore it. But they put it first to make sure that we're at least reminded that we're being bad people by ignoring our errors, that we should probably check, because well-reasoned programs check their errors. Well-reasoned programs tolerate failure, or at least understand that things can go wrong. Cool. So let's jazz it up a little bit. So we have, at this point, we have required the FS module, which is one of our built-in modules. But one of the things that I hope you have thought about here is that we would not actually want to use only the built-ins, and we would also not only want to write all of our script in one big long file, right? We would ideally want to write it in multiple files that could split it out and keep them fairly short, because that way it's easy for us to find code. It's easy for us to group code together. And it also means that it's easier for us to work together with people, right? If I'm collaborating with someone, if we break it into multiple files, then you can edit one file, I can edit the other, and when we check in, there's no chance of a collision. Whereas if we all work together on one big file, we're going to force our source control system to work a lot harder to figure out, well, if I edited this line and he edited this line and she edited this one, how do we get all those changes combined into one file? So we want to split things out. So what we're going to do now is we're going to create our own module, we don't just have to use the built-ins, we can actually create modules of our own. So let's go ahead and do that. Let's create a new module, and we're going to name this files.js. So we're just going to put it right here next to our index.js. It's going to be a new file. And this is files.js. And for right now, let's just put a console.log statement in here. So we're going to say console.log hello from the files.js module. Now, when we run our code from our command line, right now, nothing will change. It logs out file contains, but you'll notice that it does not, we do not see hello from the file.js module. Just like with the built-ins, these things are not automatically loaded for us. We have to ask that we want to load this module. To do that, we're going to go back to index, which is the file that we start with, and we are going to require this file. So we're going to create a new variable for it. I'm going to call it files. And we're going to say require, but it's going to be a little bit different from before. So when we required the built-ins, we could say FS because it gets registered as a special thing, right? They have these special one-word strings that they get declared as. But when I'm requiring a local module, one that's in the same directory as my current file, I have to tell Node that I don't want to load this from built-in or from the shared module cache. I want to load this from another file. And this is going to look familiar to those of you who have written like relative links, right? It's ./files. The dot means in the same folder, slash, and then files, and I don't have to write the .js. It's assumed that if you're loading a file in Node, you're probably loading JavaScript. So we're just going to say ./files will load the files module. All right. Once you've done that, when we run node index.js, you should see first thing, hello from the file.js module, meaning that now that module has been included, right? Because it loaded and it ran everything that was in here. When you require a module, the first time it runs that module, and then it stores it in memory. So actually every time, like we can now require it as many times as we want to. Don't do this, I'm just demonstrating. But if we were to require .files like 4 more times, right? You're still only going to see hello once because it only initializes that module once. And after that, it stores the value that comes from that module and returns it back out. Now, what is that value, right? What is the value of our module? Well, if we console.log files, the answer right now is that it's empty. It's an empty object because we haven't told it that we need to return anything different. So we say hello, but we're not providing anything. And when we define variables in one module, they are not automatically shared with other modules. So if I declare a variable in files.js, if I come over here in files and I say like var x equals 12, then trying to console.log x over in index.js will be an error. It'll say x is not defined. Because although x exists in this file, it's not available in other JavaScript files. We have to tell Node which values we want to export from one module to another. If you've used another programming language, this is basically public and private values, right? So you have your private values are everything that's in the module, and then you make things public by exporting them. And the way that we export them is we create there's a variable that already exists called module. And we say module.exports is equal to whatever we want to export. In this case, I'm going to export an object with hello world in it. We're saying the public value of this module, the thing that you get when you require files.js, is this object that I have set module.exports equal to. And this value is, or the module variable is provided for you. And then exports is the kind of like the value that it looks at on the module object when it comes time to require that into another thing. So whatever we set module.exports to will be the thing that shows up in the other module. And this can be anything. We're making it an object, but you can export a string, you can export a number, you can export a function. Several of the modules that we're going to use export a function that has additional stuff crammed onto that function, right? So like the request library, for example, will do that. But for right now, when we run our script at this point, having now exported things, we should see that the contents of that module are this object, hello world. So that's the thing that we've exported. No other variables come through. Everything else is private. And although that may seem like a hassle, this is actually a good thing, right? In a lot of other languages, we have classes, and those classes have public and private values. And the idea of privacy is that there's a bunch of bookkeeping and just kind of crap that you need to do for a lot of programming, but you don't really want to clutter up the rest of your program. So you store that in an object or in a class, and it's private, so that you're just like, well, this is my messy little like toy box, but then we have public that are the useful things you want to get out of it. In Node, modules, we do have objects, but in addition to that, modules serve as a way of kind of like sandboxing that mess away. And so that means that we can clutter up all the variables we want, but then we only export a nice clean subset to other modules. And it also means that we don't have to worry about variable names colliding, right? Like if I use X and you use X, it doesn't matter because we're in different modules. Yes?
I was wondering if I could see this.
Absolutely. So what we're going to do with our files module now is we're going to fix some of the pain points that we've got here, right? So like one of our pain points is that read file requires this extra encoding step that we always have to specify. I've been writing stuff in Node for probably like 3-4 years now. I have never, ever written anything but UTF-8 in that spot, right? Like every single time I have written fs.readfile something and then UTF-8 every single time. And it gets really old, right? Because it's just cluttering up your program. Like, what's the point? What are you trying to get out of that? So we are going to write wrappers for some of these things that will make it a little bit easier for us to read these individual files so that we can get rid of some of the boilerplate. And we're going to put that in our files module so that instead of requiring FS, we can require files to do all of our file work. So in our files.js, again, we don't share variables. So if we want to use the FS module, and we do, we need to also require it here. So we're going to require the file system. And then we're going to create a function that calls fs.readfile, but it wraps it up, and it knows that we're always going to use UTF-8. So we're going to create a function called read. And read is a function, and it's a little bit simpler than fs.readfile, right? It takes a file name, and it still needs a callback. Asynchronous functions are they're a little bit contagious, right? If you use an async function, meaning a function that uses a callback instead of an equals sign to provide its value, then every function that calls it must also be asynchronous. Because if you rely on one of these things that kind of yields to other stuff, then the whole stack of them, if any of them are not asynchronous, they'll just keep going, and they will finish too soon, right? They won't wait for that thing to complete. So we say that asynchronicity is contagious. It's infectious because it means that any functions we create that use asynchronicity must themselves also use this pattern of having a callback as their final result. And our function here is very simple, right? We're going to call fs.readFile, and we're just going to pass through the file name. We're going to specify UTF-8. We're basically just going to fill that in. And then we're also going to pass in our callback. Now, what I actually want to do, this will work, right? Like we could now read, so we could actually call this. We could say like read index.js function error data console.log data. I'm just demonstrating. Don't worry if I'm typing fast. It's okay. So I create, I'm just going to call this function. And then when I run it, we should now see, right, it logged out the entire contents of index.js right there. But what I want to talk about is the way that we continue. Like, let's say that when we get the file back, we wanted to do something with it as part of our read. We wanted to process it in some way. So we're going to pass in our own function that takes error and data. We've got our own callback. If there's an error, we need to pass that error up so that whatever callback we pass into read will get the error, right? So like we basically just pass callbacks up or errors up the callback chain until they get to somewhere where somebody decides to do something. So what we're going to do here is we're going to say, if there's an error, I want you to return, right? We're not going to continue doing things, but we're going to call back with that error. Meaning, if anything went wrong with the read, so remember, when we call this function, we're calling read, and it is calling read file for us. If there's something that goes wrong with read file, we're not going to handle it here, but we want to handle it in the function that we passed into read, right? Because this is all internal. We don't know what you want to do on error. It depends on your program. We want to let you handle it. So if something goes wrong, we immediately dump out, but we let you know by calling the callback that you passed in and passing the error up. We basically just pass the buck. We're just like, I don't know what to do with this error, but I'm going to give it to you in your callback, and you figure out what to do. If there's not an error, let's say, for example, let's do something fancy. Let's be like data equals data plus dot, dot, dot. We're being like extra mysterious, right? We're being like, this is the contents of the file, dot, dot, dot. It's like suspenseful. It's quiet. It's too quiet. What's up with this file, dot, dot, dot. And then we're going to pass that back. So callback null data. And at this point, we've changed the data a little bit. So now we've handled our error. We have, if there's an error, we've passed responsibility on that up. But we can't just, we're not returning the error directly because nothing is being set equal to this function. We're calling the callback because that's how we signal, right? We're getting a function in, and now we're going to call that function to let the consumer know. And then if it works, we'll make it past this because the error will be false, and we'll call back with our slightly mutated, with our suspenseful data, right? Let's actually try this out from the other side, because I think that makes it a little bit more clear if we can actually kind of see this from as a consumer as well. So we need to make this accessible to our other module. So in our exports, we're going to say read is equal to read, right? We're going to make this object, and we're going to say, yeah, so on the object that we export, I want there to be a read property, which is the function read that I just created. And that means that on the other side here, I don't have to use fs.read file anymore. Instead, my files object will have files.read, right? Because it's an object with a read, and that's a function. So instead of calling fs.read file, I can say files.read, pass in my file name, sample.txt. Let's crank this up so you guys can see. I don't have to pass in UTF-8 anymore. I'm freed from the encoding tyranny. But I still do have to pass in, and let's pass in our winRed function again. So everything's the same, but I don't have to pass in the encoding. But this is how I access it, right? From the module that I exported, which is an object with a read property, which was the function that we created. Now I can get to that function through the files object that is the module. So when I required that module, I got its exports, and those exports were an object with a read function. And now when I run this, this space intentionally left blank, ... right? I feel more mysterious already. This is great. In fact, once I've done this, I'm not actually using fs in here at all. I don't actually have to even include it in my index.js. I can just require files, and it provides all of the file handling stuff that I could possibly need. It's pretty cool, right? So this is how we communicate between modules. In one module, we require it. And if it's a local module, we use // and this will actually handle any path, right? Like if I wanted something that was in the parent directory, I could say .. because I want to go one level up. You can type anything, but it just has to start with a dot to tell Node, I don't want to load this from the built-ins. I want to load this from the local, wherever we are. And then on the other side, so that's on the require side, we get this object. On the other side, that object that we get from the require is whatever we set module.exports equal to. So that's how we transfer things from one place to the other. But any variables, like there is no read, just plain read in our index.js, because that variable is only declared in this module. On the other side, it comes in on this object that gets exported. Anyone have any questions about that? Okay. Oh, that's what I called it. Did your test code. So you had it called, but you didn't try to call that. What's the error that you get? Okay. I'll be right there. Okay. So UTF 18 is not. So FS, is because you can't require it itself. You have to require FS. Yeah, it's in this file that I'm using. I'm using the index.
Oh, yes.
Okay. Anyone else? Raise your hand and grab your mic. Oh, no.
So you just have to change your desktop folder and then go into the and then there's no index and it
Other people grab
That's what
the
he's saying. You don't need it.
Oh,
It's
yeah.
files.
So you're stuck in. Yes.
Yeah.
Okay. All right. Does anyone know, by the way, because it's my first day and I always forget on the schedule, what's the actual end time for this class? 8:15. Sweet. All right, got an extra 15 minutes.
8 o'clock.
8 o'clock. Yeah, nice try, Dan. You're not even doing this for credit, man. All right. Yes. You have an end.
Yeah, because my
to say that all of this stuff inside here is part of the function.
Yeah.
I don't know.
That is. Awesome. Okay. So let's talk now about one last thing. So we've got modules that are built in, right? So we've got FS, path, URL. There's a whole bunch of them. And I would really encourage you to take some time. I know. Whenever I say this to classes, like I always give classes advice, I say, go home and read other people's source code, and nobody does it. And I say, go home and read the documentation, and nobody does it. And I know nobody does it because I see their homework, and it's really clear that they didn't do it. But you don't have any homework in this class. So it would really be good if instead of doing homework, which given that my classes tend to be really difficult and everyone complains about them, you can estimate you would have spent like, on average, you guys would have spent like probably 4 hours a week doing homework, right? Some of you less, some of you more. But on average, I feel like when people complain to me about the homework load, it's because they're like, I spent 4 hours doing that. So if you have 4 hours that I am freeing up, that I am giving to you out of the goodness of my heart and the lack of my desire to do grading on a weekly basis, then the least you can do is seriously look through the module documentation and look at some of the ones, like obviously like the crypto module for doing cryptography is crazy complicated, right? I don't expect you to understand. There's a couple other ones that I don't understand, frankly, because these are core functionality, and so a bunch of them are based on other things, right? So like the file system module, like the HTTP and HTTPS and the network modules, like these are ridiculously complicated because they start a web server, and web servers are complicated. So don't look at those and assume that you're going to know what they do. That's fine. But You know, the ones that I've pointed out, file system, query strings, path, URL, a bunch of these are relatively easy to understand and pretty simple to kind of get. So please go through and look at the documentation, require some of them, and play around with them. And certainly things like path and URL, for certain, are synchronous. They don't do the callback thing because they're all, like, they don't have to talk to anything to parse a URL, right? They can just do it right away. So they're really easy to try out from the Node command line with the little, the angle bracket prompt, because you don't have to like pass in a callback to get the value. You can just type url.parse, pass it a string, and try it out, right? I'll demonstrate. It's super easy. So if I'm here at my console and I type node to start up my command line, and then I say var URL equals require URL, then I can look at that module by just typing its name, right? So I can see that the URL module has, exactly like the documentation tells me, 5 things on it, right? It's got functions for parsing, resolving. I don't know what resolve object does. I've never used it. It doesn't matter. Format, and a constructor. And then if I want to, I can try these out. So I can say like url.parse, and I can pass in our GitHub repo. So I can say github.com, Thomas Wilburn, ITC 298-materials. And I can see what it gets back right away, right? I didn't have to pass a callback, didn't have to create a function. So these are really nice, easy, fun modules to play with. They're really simple. They don't, but they're good practice for like, I'm gonna require something, then I'm gonna use it, I'm gonna see what this can do. So these are good things to mess around with, but it's good to just like flip through the documentation. In general, when we use a scripting language, we spend a lot of time interacting with the file system, right? Like when you use PHP or when you use something else, like a lot of you have probably used PHP, and I know for me as well, most of the time, if you're writing a really simple PHP page, you're probably only using it to like include the headers so that you don't have to write the header on every page, right? So you're just like loading the header. That's basically just a file system operation, right? You're just combining 2 files, and PHP automates a chunk of that, but that's all it's doing. So these are really good modules to know, at least reasonably well, to have a passing familiarity with, to be able to look at. But these are the built-in, and then we have modules that we write ourselves. And if we were assuming that we would have to do everything from this base, this would be a really depressing class, right? And also Node would not have been terribly successful. If the idea is that everybody starts from the base modules and then they write everything on top of those, everyone has to do everything from that point on, from scratch, right? There would have been no take-up because nobody would do that. That would be a ton of work and everyone would get really frustrated and they would quit. Part of the advantage of Node is that it comes with a package manager to install other people's modules. It makes it really easy to use third-party stuff, kind of the way that jQuery became very popular because it had plugins, right? You could load a jQuery plugin and all of a sudden you've got a carousel. I load a jQuery plugin, bam, all of my color pickers work, right? So in Node, what we use to install third-party libraries is we use npm. And npm is it's Node Package Manager, but they insist that that's not what it stands for. They have like this thing. If you go to like npmjs.org, they'll be like, nice people matter. You know, they've got all these like hippie kind of things for, oh, that's what npm stands for. It's kind of hilarious, actually. npmjs.org. What do we get here? Naughty pterodactyl made, right? They spit out a random one. Every nice people matter. Yeah. Nifty procrastination machine. But from npm, we can load third-party libraries that let us do other stuff. And in some cases, let us do really complicated stuff that we would not want to write ourselves because it is so complicated. So for one thing, like you can go here and these are all of the like very popular packages that are used. You may recognize some of these. And we're going to talk about like Grunt and Less. Browserify we're going to use down the line. It's great. You can also search this for things. So you could search for, you could be like, I would like a responsive frame. And then when you find that, you would find, hey, look, it's the Seattle Times component responsive frame, which allows you to create iframes that expand and collapse when their content expands and collapses, which is awesome. We use this all the time, and we've published it to NPM so that other people can use it and so that we can use it inside the building. We can share it. So how do we take advantage of this? We've got this huge chunk of third-party modules. How do we get them installed? I mean, the jQuery way would be that we go to like the jQuery download page and we download it, we manually copy it to the page, and that would be awful, right? That is not a good way to manage software. So instead, with NPM, what we do is from our command line, from our $, our basic bash prompts, we have an NPM command. And if you type NPM, it'll give you like a list of all the things that it can do. And it'll also give you NPM help. So you can say like, oh, I want to know NPM help install. And it'll actually like open up a web page. I don't know why it opens Internet Explorer, don't ask. But it'll list the manual for you, right? Like it's very friendly. So when we want to use something, we can use NPM to install this library directly. And it will go out and download it and put it in a standard place and make it available to us in our scripts. Let's give this a shot. So what we are going to do is we are going to use one of my favorite node modules, which is request. And request lets us go out and request web pages. So we can go and download like google.com and then do stuff to it, which is kind of neat, right? If you've ever wanted to write like a scraper that goes out and gets web pages and then looks at them for information and saves it, Forrest knows what I'm talking about. This is the thing that I do all the time, right? Like I have a current project at work at times where we're working on a traffic page. We use data from WashDOT and we go and download it off of their pages and then parse it and we put it into a nice friendly thing instead of WashDOT's like hideous Google map that they have, so that we can tell you if you're going to be late. We use requests to go out and make that. We tell it, hey, go out and get this page for me. And it does. And if you had to write this yourself, it would be really hard because it turns out that requesting pages, there's a lot that can go wrong. You can hit a redirect, you can hit a weird server code, you might type in the wrong URL, you have to like spin up. It's all these nested callbacks, but request makes it one step. So we're going to install the request module. We're going to say npm install request. And you're going to hit enter. And it is going to spit out a ton of stuff that it's downloading, right? It's going to go and download all this crap. Because request itself is built on top of other modules, right? Like request needs to parse URLs, or it needs to handle regular expressions, or it needs to store cookies. So there's another module that it uses called tough cookie. Or it might need to handle form data. So you have modules in Node, you have modules built on modules, right? Like you have little pieces of code, and then by building those and gluing them together, you end up with really cool things like this library. So if we look at this now, inside the folder, you're going to notice that it's created a subfolder called node_modules. That's where all of your installed modules go for a project. And if you look at the documentation for the class in the repo this week, you're going to see that there's actually it talks about normally we create a package.json, and we'll do that next week so that, because we don't normally check this in when we use source control, because if I check it in, it's like literally thousands of files, and they're all going to be the same as they are when you hit node or npm install request, so like why duplicate it? So we use a package.json to basically create a recipe of like, these are all the modules I have installed, so that when someone else works on it, they can just install those with one command. But if we look inside of node modules, there's request, right? And then inside of request, it has its own node, it has all of its code, and then another node modules. And inside of here, if it's a big enough thing, there's probably another node module inside of those, right? So like, tough cookie has more node, like it gets very deep very quickly. But these are all local. You have a local copy of these modules, one for each project. So each project will have its own node modules folder. And once we've done that, then we can require it from, say, our index.js just by requiring it the same way that we do the built-ins. So we don't have to use a dot. Instead, we might say var request, scroll up here, var request is equal to require request. And because it's installed in node modules, and that's a standard place that NPM puts things, we don't have to tell it exactly where that is. It will know that if this is not one of the built-ins, it will look in that folder first. And then it will look, there's a hierarchy of other locations that it'll look, culminating in local files. But this is where it'll go, right? So once we've installed something with NPM, it basically becomes a built-in for us. It gets treated the same as all of the other built-in modules. And so now we can use this request function to ask for a web page. So let's go and download one. I'm gonna request actually the class page. I'm gonna request the raw version of it. So if I go here to like readme.rst and I'm gonna look for the raw, and that's gonna give me this long, awful URL. But you can honestly type in any URL you want. It doesn't matter. And I'm gonna say, when we call request, request takes the form of a function. It needs a URL. Oh man, I'm gonna store that in a variable because otherwise this is gonna be unreadable. Hang on. Var URL equals that. Excellent. Here we go. And I'm gonna request my URL. And then because again, this is asynchronous, right? It takes time for Node to contact the other computer on the internet, resolve the domain name, download the file. All that stuff takes time. So this is another asynchronous thing, and that means that we need to pass in a callback. So we're going to say function. As always, the first thing in our callback is an error in case something went wrong. Maybe I got the URL wrong. Maybe GitHub is down. I don't know. Anything could happen. And then there is a response object that we're going to ignore, and the body. And if you were curious about like why I use these, when you look at the NPM modules homepage for request, for example, this is the example. Like this is what, when you call this function, that's what it expects back. But it has really good documentation, right? It'll talk all about like, here's how you can get things and you can pipe them from place to place. And it's very elaborate, very cool. So in our callback, we got the body, and I'm just going to console.log body.length because it's a very long document that I just downloaded. It doesn't, you could just go to like google.com if you wanted to just download something. It doesn't matter what the URL is, just anything that you can visit in a browser. But the class repo is thomaswilburn/ITC298-materials. And you could get that too if you wanted to, like you would just get the GitHub page. So when you run this, we should now see, so we're going to say node index. And when we run it, you'll see that it took a little longer for it to run, right? Because it took a little while for it to go out to the internet, and then it got that, and it said that, okay, this body is 7,117 characters long. So we could log that out. It happened after all of the other code. I'll add a little bit of like a note here. I'll be like, body length is that. But that's all that's required to use these third-person libraries. And there are libraries for literally everything. One of the things that I went looking for today, and then was, I can't tell if I was surprised or not when it actually existed. I found a library that lets you convert colors to simulate color blindness. There's actually a module for that. So you can be like, I would like to take this color red and this other color, and if somebody is red-green colorblind, what do they actually look like today? So there's a color-blind module, and you can npm install that, and then you can use it to convert colors to their colorblind form and see if your graph works. Whereas I put out a graph this week that I should have used that because I used 2 colors, and then I got nasty Twitter messages from people saying, I'm colorblind and I can't tell the difference between your lines. And I was like, oh, that sucks. Nobody likes that. So all of these, there's this vast world of modules, and that's the other thing that's not really your homework, but would be a really cool thing for you to do, is play around and look at some of the modules that are available. You know, go to NPM, pick something that you're interested in, if you have ideas for what you want your final project to be, and see if there are available modules that you could install that would help you do that. For example, you might be interested in optimizing SVG, right? Like maybe you use a lot of SVG icons. So you might go to npmjs.org, you might search for SVG, and you might find, oh, there's a whole bunch of things that I can use here. And if I search for optimize, I should actually, here's SVGO. Here's a module for optimizing vector graphics files. And then if I want to, and it's in Russian. So if you are Victoria, you can read this. And the rest of us will click the little translate button in Google to enjoy that, which is really fun. I'm glad I could make your day with that. And the fun thing about this is, like, one of the things that I think is really neat. So this is actually used, this module is then being used for a web app called SVG OMG, which is a web app that optimizes SVG files. You drag them in here, and then it simplifies them and crunches them down so that they take up less room in your browser. And that's all done, this is actually being done on the client side with NPM. So NPM is so powerful. You can even, we're going to use it on the server, but we're also going to look at later on in the quarter, we're going to be able to use this on the client. You're going to be able to take advantage of all of those modules and even use them in the web pages that run on people's browsers without having to run a server at all, right? So NPM is incredibly powerful and a super cool resource. And that's kind of the other thing that I want to look at. So let's sum up what we talked about today. I got 6 minutes to go, so let's pack it full. All right, so we talked about the node command. We talked about the command line first. I'm going to add, it is not there yet, but I will add a primer on the command line for those of you who are still a little nervous about moving around and CD and all that stuff. There will be a file added to that folder that will be command line basics and a tutorial so that you can look it over. So we use the command line to start the node interpreter, and that lets us run things at the console so we can try stuff out. But then we can also run scripts by using node and then specifying a JS file, so wherever it is that we want to start. Within that file, we learned that node does not allow us just to set things equal because it's non-blocking, right? It's asynchronous. So that means that when we use stuff like the file system module, instead of being able to say contents equals read file the way that you would in PHP or Python, you actually have to pass in a function that will be called once that result is read. So it's asynchronous. And you'll start to see one of the things that we're going to talk about next week, even just in here, we're entering the callback pyramid of doom, right? Where like the more things that we were to put in here, the deeper you get, and eventually you end up with like, it almost looks like a bunch of birds flying, right? It's just like this triangle of like nested callbacks, and it gets deeper and deeper. We're going to look at tools that are going to help us avoid that callback triangle of doom. But in the meanwhile, we also created functions that could call out to that and then pass back either errors, which are always the first thing in a callback, or data, which is what follows the error. And there can be multiple things, or in the case of read file, there might only be the contents of the file. That's all you get back. And then because we don't want to have to write one big file, we talked about how we can require the core modules, like FS, but we can also require modules that we write by putting a dot in front of them and writing our own file. And from those files, we export values that we want to make public to other modules. Otherwise, nothing is shared. So only the things that are on exports get shared between those files. And finally, wrapping up what is a very busy first day, I'm very proud of you guys. We talked about how using NPM, we can install third-party modules without having to go out and search for them and FTP them down from the internet, right? We just say npm install this thing, and it downloads it, and it makes it available just the same as the built-ins, right? It puts it in our node modules folder, and it makes it available to us so that we can use all of that amazing third-party code that all of these like busy little JavaScript bees have been working on for the last 5 years. So that is our first lecture. At this point, you should be in a good condition to start messing around with this. There is so we will not have a lab this Thursday. I'm going to be out of town. I apologize for that. It's a really crappy way to start the class again, but it's the way it is. But there is a lab.rst in the repo in the Intro to Node folder. And it would have been what we would have done on Thursday for a lab. What we will probably do next Thursday is an adaptation of that. But it's to write a scraper for Wikipedia using request and another module called Cheerio that basically acts like jQuery on pages that you download. And so it will let you go through and scrape and look at that file and download whatever things it is that you want. And if you're interested, I'd love for you guys to try out that lab on your own and then come back and tell me what went wrong. This stuff probably will. And that's how we're going to figure out how to pace the rest of the quarter, okay? So if anyone has any questions, I can take those now. I'll stick around for a little while. Otherwise, I will see you next Tuesday. Thank you so much for coming to class. Let me shut this down real quick.